hopefully you at least printed out the review sheet. That's something, right? All right. You put your name on it? All right. You're ahead of half the class. Right, so, well, that's the important one. So I give you 3 functions. I give you f of x equals 4 sine x. And g of x equals cos 4x. And then h of x equals tan inverse of x. And then part B asks you to calculate f of 17 pi over 12, over 2, minus g of 13 pi over 3, plus h of negative root 3 over 3. So given these 3 functions, we have to calculate this expression. So how do we do it?
Very carefully.
Very carefully, that's right. What should I start doing?
17 over 2 into that.
Right, so each one of these is function evaluation. You have to plug what you're given into the correct function. So f of 17 pi over 2 means you're going to write 4 sine and then copy 17 pi over 2. Minus g of 13 pi over 3 means you take cosine, keep the 4 inside, times 13 pi over 3. Right, that's all inside of the cosine function. Plus, h is tangent inverse, so you'll write tan inverse of negative root 3 over 3. And then each of these you're going to have to calculate using triangles or your unit circle or something. Sine of 17 pi over 2 I can do right away, well, pretty quickly. Where does 17 pi over 2 land?
Positive.
Let's see, so if I divide this out, 2 goes into 17 8 times with a 1/2. So 17 pi over 2 is 8.5 pi. Here's 8 pi. So 8.5 pi is going to land up here. Which means my sine value is going to be 1. So for this part of the expression, I'll copy the 4 down times sine of 17 pi over 2 is 1. Minus, now before I can do the cosine, I have to multiply out here. Right, you have to take 4 times 13 pi over 3, which becomes, make this 4 over 1. So it'll be 52 pi over 3. And then 3 goes into 52 17 times with a remainder of 1. So 52 pi over 3 is going to go to 17 and 1/3 pi. 17, all your odd pi's land here. Right? 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. All your odd pi's land here. And then because of that 1/3, you go out 1/3 down to here. And you have to remember, or have a picture of a unit circle, or remember your unit circle, but this is going to be negative 1/2, negative root 3 over 2. So your cosine value at 52 pi over 3, negative 1/2. So because there's already a negative here, you're going to end up getting a plus there. And finally, tangent inverse of root 3, negative root 3 over 3. How do you do that? So tangent inverse, every inverse function is asking a similar question, a related question. Right? In order to do tangent inverse of negative root 3 over 3, you have to figure out where tangent of theta equals negative root 3 over 3. So you're working backward when you have an inverse function. You're given a tangent value of negative root 3 over 3. And you have to figure out the corresponding angle that got you there. So this guy is negative pi over 6. Remember, the way tangent works is it increases as you go away from the x-axis. So if you were to draw your first quadrant tangent ratios, they would go root 3 over 3, 1, root 3. So if you're dealing with any type of root 3 over 3, whether it's positive or negative, you know you're going to have a pi over 6 reference. Since you end up in the fourth quadrant, since tangent's negative in the fourth quadrant, you know this whole thing is going to be negative pi over 6. So now you just have to calculate 4 plus 1/2 minus pi over 6. Which I guess you can get a common denominator, which would be 6. Make this 4 over 1. Multiply by 6 over 6. Multiply by 3 over 3. 24 over 6 plus 3 over 6 plus pi over 6. Oh, minus pi over 6. 27 minus pi over 6.
I have a question.
Yes?
So when tangent is tangent inverse, we don't take the coordinate, we take the pi over 6,
Right, when it says inverse here, you're always looking for an angle.
an angle.
Yeah.
Okay. I have another yes or no question.
No.
Oh,
Did I get it right?
that'd be nice if that was no. Do we have to memorize the law of sines and cosines?
Oh, that reminds me. So, if you look on, not the beginning page, not my home page, because for some reason I didn't put it here, but if you look on the Math 127 Study Aids page, there's a formula sheet I posted. This is the formula sheet I'll give you for the final, so you know everything you'll have.
So what's on here is what you'll be providing us?
Correct. I will provide you with a copy of this sheet.
So then we don't need to.
That's correct.
Okay. Can we do number 13?
Maybe. Did you want to do another one too?
12.
12.
And then 13.
Oh, and then 13.
They
Oh,
both
okay.
stump.
Yeah, both of those
Okay. Yeah.
Couldn't get the angle right, drawing it just correctly. It's hard to do with the word problem.
All right, so let's look at 12 and 13, and then we got to move on. So, well, the leaning tower of Pisa was originally perpendicular to the ground. Because of sinking into the earth, it now leans at a certain angle theta from its original position. So, we have this tower. It was originally perpendicular to the ground. All right, ground, tower. What are we doing there? Ooh, sweet. Windows, all right. Maybe a little angle on top. It doesn't down on top.
It's the leaning tower.
So, it was originally perpendicular to the ground, right? So originally it was at a right angle. But then it started sinking. So now it says it now leans at a certain angle theta from its original position. So it leans at a certain angle theta from its original position. So this is no longer a right angle. Now, because it says it leans at a certain angle from its original position, you're supposed to measure from a vertical. Right? Here's its original position. This is the angle that it leans at. Theta. An observer standing 150 feet from the tower on the side the tower leans toward. So you're standing over here, the side that the tower leans toward. Notes that the angle of elevation to the top of the tower is 53 degrees. So over here, little guy, he sees his angle of elevation to the top of the tower is 53. 53 degrees. And then he's standing, oh no, it doesn't tell you where he's standing. Oh no, he's standing 150 feet, it does tell you. So he's standing 150 feet from the base of the tower. And then the tower is 179 feet tall. So 179 is going to be this side of the triangle right here. Does that make sense? we're ultimately trying to solve for theta, right? This angle that it started leaning. How are we going to get to theta?
So we should try to find the angle that's on the bottom left.
Yeah, so if we find this angle in the bottom left, which we can use what to find?
Let's see,
Law of sines, because you have side, side, angle. So you can use law of sines to find this angle, eventually. And then once you have that, how do you get to theta?
Subtract it from 90.
Subtract it from 90. Right? Because this entire angle from a vertical position down to this guy is 90 degrees. So if you take out this chunk, if I draw it like this, it'll get a little more clear. This whole thing is 90 degrees. This is your tower. So if you take out theta from 90, or if you take out this angle here from 90, then you'll have theta left over. Okay. So let's call this angle something. Let me label it like I normally label triangles in the law of sines. I have big A, big B, big C. And then I have little a, little b, little c. I want to solve for big A, but I don't know little a yet. So that's going to be annoying. So what do I have to set up here? Yeah, so you know C and sine C, and since you have little b, you'll be able to solve for big B. But once you have big B, actually, it's not too hard to get to big A because you know you have to add up to 180. There's not too much of that here. So I would set up C over sine C equals B over sine B. 179 over sine 53 equals little b, which is 150, over sine big B, which we don't know. So multiply 179 sine B equals 150 times sine 53. Divide by 179. And after you get an approximation, or after you get a decimal for that, you have to take sine inverse to get what B is. Anybody have an approximation for this for me? Somebody whispering to test my hearing.
0.6692.
0.6692.
See if that comes out to 42 degrees.
Oh, I don't know, is that...
I got .331.
I got something different for both of those. I'll try again.
Okay, all right.
669.
I got
Yeah, she's correct.
She's right.
You got .6692. How many people got .6692? Oh, okay, that's enough.
That's roughly right.
That's enough. If we fought, we would. That means we're right. So then, sine inverse of that,
42 degrees.
B approximately equals 42 degrees. That's wrong. That's wrong. There's no way this building's still standing if it's got 42 angle right there.
No, that's B, not.
Oh, okay, all right, good. Thank you. Good point. Let me wrong. All right, so that's B. Keep track of what we're doing here.
We can't find A until we find
Yeah, we haven't found A yet. All right, good. How do we get A? We'll subtract, right? So A will equal 180 minus 53 minus 42. Oh, so 95, so 80? 85? That. Does this angle here is 85 degrees.
So, then we just do 90 minus 85.
Yeah.
That's 5 degrees.
Theta will equal 90 minus 80.
So 13 then.
How come, by the way, I'll definitely do 15 in a second. How come, remember, when you do law of sines, you're always supposed to consider two possible triangles, right? Either b is equal to sine inverse of this, or you do 180 minus, right? So our other possibility is 180 minus 42. How come we didn't do that?
So C is 58. I don't know.
Does it just make any sense, right? I mean, a couple of reasons. One, first of all, if you do 180 minus 42, what do you get?
138.
130.
Which wouldn't make sense.
Minus 42 equals 138. You can't even have a triangle that has a 53 degree angle and a 138 degree angle, right? I mean, so that doesn't make any sense. More than that, if this angle was 138, this guy would have to be so small that it wouldn't make any physical sense.
It wouldn't be leaning.
It would be falling, right? But you know, in non-application cases, you do want to consider that you could have two triangles. Okay? So whenever you solve for your first angle and side-side angle, always do 180 minus each other option. All right. Rule number 13. So the length of daylight present each day is a periodic function of the proportion of a full year that has passed. The longest day of the year has 14 hours of daylight and occurs half a year after December 16th. And the shortest day of the year is December 16th, which only has 10 hours of daylight. Express the hours of daylight per day as a function of the proportion of the year that has passed. So lots of words.
Shortest day was December 21st.
What?
I thought the shortest day was December 21st.
Well, in this application, it's December 16th. Maybe it's a different planet. All right, so let's before I actually answer before I actually address the question, which wants me to find some sort of function, let me draw a picture of what's going on here. So the length of daylight present each day is a periodic function of the proportion of a full year that has passed. So your length of daylight, so the amount of daylight each day, is a periodic function of the proportion of a year that has passed. Now what it's saying is the longest day of the year is 14 hours of daylight and occurs half a year after December 16th, and the shortest day of the year for this application is December 16th, which only has 10 hours of daylight. So what happens is you have one, let's put 1 year over here, and we'll put half a year here, and we'll put 0 years here. We'll start measuring time on December 16th. And at that point in time, we have 10 hours of daylight. So if I were to measure how much daylight we have, we would be up here at 10 hours. Then the longest day of the year is 14 hours of daylight and occurs half a year after. So after we go 1/2 of a year, we have 14 hours of daylight. So we're up here. And then after a full year has passed, we're back where we started. And we just keep repeating in that fashion. So our function that models the length of daylight, something like this, which can be modeled by a sine or cosine function. And in fact, I tell you, you should write your function as L plus A cos omega p. So this function we're going to write as f of p. Oh, I forgot my A. L plus A cos omega p, where p represents the proportion of a year that has passed. So when p is 1/2, we'll be up at 14. When p is 0, we'll be down at 10. This guy would be 1, 10 again. So what do all the letters here mean? What does A mean? Amplitude. That's how far above and below some sort of equilibrium your cosine function goes. Omega is related to what? Frequency of the period, right? Omega can be calculated from the period or the frequency. So if I know period, I know omega. If I can figure out how high and low my function goes, I know A. What do you think L is?
Vertical shift.
L is your vertical shift, right? It's outside of the function, it's being added. So the first thing I would try to figure out is how far up has my function been shifted? I heard 10 and I heard 12. So if you compare this to a regular cosine function, here's a regular cosine function. It starts up at a max, goes down to a min, and comes back up to a max. How far has this been shifted? It hasn't, right? Because it's oscillating around 0, right? But the min is at -1 and the max is at 1. So to figure out how far you've been shifted, you actually take the average of the min and the max. So this guy is oscillating around 12. The average of the min and the max value is 10 and 14. Once you know how far you've been shifted up, you can read off your amplitude. What do you think your amplitude should be? 2, right? Because it's going down 2 and up 2 as it oscillates around 12.
Would it be -2?
Yeah, so the amplitude is 2, but you definitely want to put a negative in front of the A. Why? Because at 0, you're at a min. Absolutely. So P is our variable. That's the proportion of a year that's passed, which means all we need now is omega. How do we calculate omega? I looked at 12 and I said the distance to the minimum is 2 units. And the distance to the maximum is 2 units. So that's what the amplitude means. How far do you go from this equilibrium to the max? Or to the min. For omega, you can use the equation period equals 2 pi over omega. What's the period in this case? So the way we set it up, it's 1, right? 100% of a year. So after 1 full year, you've gone period. Set that equal to 2 pi over omega. So omega is equal to so my function should be 12 minus 2 cos omega. Oh, not omega. I know what omega is. 2 pi p. This is kind of like simple harmonic motion. Remember when we had the A and the omega? Except it's slightly more complicated and you have a vertical shift.